Welcome to the mathematics on my channel. In this video we are going to solve nice integral from 0 to 5 over 2 x times sine of x times natural log of sine of x dx. Okay, how to begin? Well, first I is equal to integral from 0 to pi over 2, here x times sine of x, then here we have natural log of sine of x. I think the Fourier series of natural log of sine of x is equal to minus natural log of 2 minus infinite sum 1 to infinity cosine of 2nx over n here now dx. In the previous videos we also use this Fourier series formula. Okay, then we can write now we can break our integral into two different integrals. So here minus times natural log of 2 is a constant, so we can write outside of the integral sign. Then here 0 to pi over 2 x times sine of x dx, then here minus integral from 0 to pi over 2 infinite sum n is equal 1 to infinity. Now we have x times sine of x cosine of 2nx over n dx. Okay, then here minus natural log of 2, I'm going to rewrite this integral x times sine of x dx. Then we know according to Fubini's theorem we can change integral sign and sigma notation. N is equal 1 to infinity integral from 0 to pi over 2. Now here x times sine of x cosine of 2nx, so we can use trigonometric formula. So we can write this is equal to sine of 2n plus 2nx plus x, so 2n plus 1x, then minus sine of 2n minus 1 of x over, here we have n, but here we should put 1/2 using this formula. We have 1 over 2, so 1 over 2 times n, and here dx. Okay, then we can write minus natural log of 2 integral from 0 to 5 over 2 x times sine of x dx. Then here minus now 2n, we can write outside of the sigma notation, 1 over 2 outside of the sigma notation, 1 to infinity 1 over n outside of the integral sign. So we can write this is equal to now integral from 0 to pi over 2 x times sine of 2n plus 1 of x, then minus here now I'm going to write dx minus integral from 0 to 5 over 2 x times sine of 2n minus 1 of x dx. Okay, then we can take this integral is equal to I1 and this integral is equal to I2 and this integral is equal to I3. Okay, now we have three different integrals. So but these integrals are here x times sine function, here x times sine function, here x times sine function. So I'm going to take the general case integral of x times sine of k times x dx. Now we can use di method to integrate. So here di, then here x, here sine of kx, then derivative of x we know 1, here integration, so minus cosine of kx over k, then here 0, here again minus sine of kx over k square. Okay, here plus minus plus like this, then we can write I1 is equal to x times sine of x. So we have now x times cosine of kx, so minus x times, now k we know 1, so x times cosine of x plus sine of x from 0 to pi over 2, and if we plug in values, we know here we have 1. Then I2 we know now minus x cosine of kx over k, so minus x cosine of, now instead of k we have 2n plus 1, so cosine of 2n plus 1 x over 2n plus 1 plus sine of 2n plus 1 x over 2n plus 1 square, here k square, so 2n plus 1 square from 0 to pi over 2. Now if we apply limit, we know this part will be 0, and here sine of 2n plus 1 times x, we know cosine of n5, and cosine of n5 we know minus 1 to the n, so here we have minus 1 to the n over 2n plus 1 square. Okay, then we have to evaluate I3. So I3 we know, now instead of k we have 2n minus 1, so minus x cosine of 2n minus 1 times x over 2n minus 1 plus sine of 2n minus 1 times x over 2n minus 1 square from 0 to 5 over 2. If we apply a limit, we know this part also 0. Then here we have minus 1 to the n over 2n plus 1 square. We can write now I is equal to minus natural log of 2 here minus now 1 over 2 infinite sum n is equal 1 to infinity 1 over n times, now here we have I2 minus 1 to the n over 2n plus 1 square, then here minus I3, so plus minus 1 to the n over 2n minus 1 square. Okay, then we can simplify here minus natural log of 2, then here minus infinite sum n is equal 1 to infinity, here we have 2, here we have n, so I'm going to multiply by n and minus 1 to the n as a common factor, so here we have 1 over 2 times n plus 1 square, then here plus 1 over 2 times n 2n minus 1 square. Okay, then minus natural log of 2 minus n is equal 1 to infinity minus 1 to the n. Now we can simplify this. Here if we take 2n plus 1 then here minus 2n plus 1 square, so 2n plus 1 minus 2n get cancelled, so here we have 1, and same as here, same as we can write this part is equal to minus 1 over 2 times n 2n minus 1 plus 1 over 2n plus 1 square. Okay, then again we can simplify minus natural log of 2 minus n is equal 1 to infinity minus 1 to the n times, now again we can simplify this part like 1 over 2 times n minus 1 over 2n plus 1, then here minus also we can simplify this part like again 1 over 2n minus 1 over 2n minus 1, then here we have minus 1 over, sorry, here 2n plus 1 square, here we have 2n minus 1 square. Okay, then here minus 1 over 2n plus 1 square, then here plus 1 over 2n minus 1 square. Okay, again we know we can take sum of these two parts, sorry, this part. So 1 over 2n, 1 over 2n, we know 1 over n, so we can write here minus natural log of 2 minus sum of n is equal 1 to infinity minus 1 to the n. Now we can multiply by minus 1 to the n, so minus 1 to the n, here 2n minus 1 square, so 2n minus 1 square, then here 1 over 2n plus 1 square, and here okay, I am going to take parentheses. So here we have now 1 over 2n minus 1 square, so minus 1 to the n over 2n plus 1 square, then 1 over n, so we have plus minus 1 to the n over n, then minus 1 to the n over 2n plus 1, then again minus 1 to the n over 2n minus 1. Okay, then we know the infinite series representation of Catalan's constant is equal to infinite sum 0 to infinity minus 1 to the n over 2n plus 1 square. Well, then we have here minus natural log of 2. Now here 1 to infinity 2n minus 1 square, but here 0 to infinity 2n plus 1 square. So we know this is equal to minus times Catalan's constant. So here also minus, so we have plus g, and here we know here 1 to infinity, here 0 to infinity. So when n is equal 0, we know 1. So here we have 1 minus g, so minus, so g minus 1, and here we know plus natural log of 2, and also you can simply evaluate these two parts. We know this is equal to 1, so minus 1. Then we know natural log of 2 get cancelled, and here 2 times g minus 2. Okay, this is the answer for this integral.